This video is on solving quadratic equations, specifically solving by factoring. I'm going to be doing examples of solve the following by factoring. I must do this method because it's telling me exactly which method to use. So solving by factoring, we have to factor the quadratic equation by making sure that our quadratic equation is equal to 0, and then we will factor it. Then once we have it factored, we'll use the zero product property, which states that if a times b is equal to 0, so our two expressions are equal to 0, then we can set each expression, each factor, equal to 0, and then solve for that expression, for that value. So number 1, we have 3x squared minus 20x minus 7 is equal to 0. This is in standard form, and it is equal to 0. Therefore, we want to go ahead and start factoring this. The GCF of this problem is 1. This first term is not an entire perfect square, so this is not a perfect square trinomial. So I'm going to be using guess and check. You can use any method you would like to use on factoring, but it must factor. So my factors of 3x squared are 1x and 3x. My factors of 7 are 1 and 7. So I have two sets of parentheses equal to 0. So I put my 1x and my 3x in the front. I look at my signs. I know that this c value is negative, so therefore I will have a positive and a negative sign in here. Don't know which one it is yet. I want to end up getting a 20x. So when I guess where I put my numbers, if I put the 1 here, that would be 1 times 3, and then 1 times 7. 3 and 7 will not give me a 20. So if I put my 7 here, 7 times 3 is 21, and then a 1. 21 and 1 will give me a 20. So I put 7 here and a 1 here. So I know I have to get a negative 20. So that means a smaller number minus the bigger number. So the 21 is what needs to be the negative. So I know I have negative 7 here. That'll give me a negative 21 and then a positive 1. Negative 21 plus 1 gives me a negative 20. So this is what's factored. This will be 3x squared. Multiply here will be a negative 7. Negative 21 plus 1 is negative 20. So this is factored correctly. So now I take my expression, my 1x minus 7, so x minus 7, and equal it to 0 from the zero product property, and my 3x plus 1 and equal it to 0. Now I solve. Add 7 to the other side, so we have x equals positive 7. We're going to subtract 1 and then divide by 3, so x will equal to a negative 1 over 3. These are our two solutions, and we're going to keep it as x equals because it says to solve. We're just finding our x-intercepts the same as m and n, but we're just leaving it as x equals instead of writing them as coordinates. On this next problem, we have x squared plus 7x equals 18. This is not in standard form, so we need to get in standard form, and it needs to be equal to 0. So x squared is our quadratic term. 7x is our linear term, so that's the next one. But we need our constant on this side, so we need to subtract the 18 equal to 0. So our GCF on this quadratic equation is now 1. This first term is a perfect square. This last term is not a perfect square, so it is not a perfect square trinomial. Means I'm going to use guess and check. So I'm going to have my two sets of parentheses equal to 0 because it's an equation I need to keep equal to 0. The factors of x squared are x and x. Factors of 18 that'll end up giving me 7 are going to be 9 and 2. 9 and 2. I need a positive 7, so I need 9 minus 2. So a positive 9 minus 2 will give me that 7x. I have factored it. Now I need to solve. So I take the expression x plus 9 and equal it to 0. I take the expression x minus 2 is equal to 0. Because if this parenthesis set is 0, this is 0 times all of that, which will give me 0. So if we solve, we'll end up with x equals a negative 9 and x equals a positive 2. Those are our two solutions. Again, we're not writing them as x-intercepts. we're finding them, they are x-intercepts, but we don't write them as coordinates. We're writing them as solutions because it's asking us to solve. Because it says solve, we want an x equals in the end. On this next problem, it's also not in standard form. We need to get this in standard form by writing 2x squared plus 4x, then minus 6 is equal to 0. Ax squared bx c. Now we need to try and factor this. Our GCF is actually 2 this time, so we're going to have 2 parentheses. X squared plus 2x minus 3 is equal to 0. So we factor 2 parentheses, we're going to have 2 sets of parentheses equal to 0. Factors of x squared are x and x. Factors of 3 are 1 and 3. I want a positive 2, so it's got to be 3 minus 1, so it's going to have minus 1 and a plus 3. Now, this expression, so the 2, the GCF, does not have an x with it, so I cannot worry about that because I can't solve for this 2. This expression has an x with it, so I focus on that one. So we have x minus 1 is equal to 0. And then this expression has an x with it, so it's x plus 3 equals to 0. When we solve, we have x equals a positive 1 and x equals a negative 3. Those would be our 2 x-intercepts, so those are our solutions. On these next 3, again, still getting them in standard form, we have our quadratic x squared. We need our x on the same side. So we need to make sure it's equal to 0. So we have 16x squared minus the 8x is equal to 0. On this equation, our GCF is going to be, our smallest number is 8. So 16 is divisible by 8, so our GCF will be 8. But they also both, there's only 2 terms here, they both have an x in it. So we can factor out an x as well, because I can take out one x from both of these. So we divide, we're going to have 2x minus 1 is equal to 0. Now because we factored out the GCF, we still have to look inside the parentheses. It's 2 terms, so we look for a difference of squares. This first term is not a perfect square, so that means that we cannot factor it further. I don't even have to look at the rest of it. This term right here is not a perfect square, so this factor is done. Now we need to solve. On this x, it does have an x with it, so I need to set that x, not the 8, just the x, because this x, I could actually put parentheses around that x to see my 2 different factors, just like I did up here with my 2 different x's. This x expression needs to be set equal to 0. And then this expression of 2x minus 1 needs to be set equal to 0. And now we solve. This expression right here is already solved. I can't get x. X is already alone, so I can't do anything to it. X is equal to 0. This one we have to add 1 and then divide by 2. So x is equal to a positive 1 over 2. Those are our 2 solutions. X equals 0, so our intercept would be 0, 0. And then x equals 1/2. On number 5, again, we need to get this in standard form. So we need to have it equal to 0. Our quadratic term needs to be first. So we have 3x squared. Then we subtract the 48. Now, again, because it says by factoring, we have to factor this because it says solve by factoring. GCF of here is going to, your smallest number is 3. 48 is divisible by 3, so we have 3 parentheses. X squared minus 16 is equal to 0. We factor out GCF. We have 2 terms. We look for a difference of squares. We have a perfect square, and a subtraction. So all 3 of those make it a difference of squares. We have to factor this further. This becomes 3 is still our GCF. 2 sets of parentheses equal to 0. Square root of x squared is x. Put it in the front of both. Square root of 16 is 4. Put it into the back of both. Difference means we're going to have one positive and one negative inside of our factors. This is now factored. Now we set our expressions equal to 0. 3 does not have an x with it. X plus 4 we need to focus on because it has an x. So we have x plus 4 equals to 0. Then we have x minus 4. X minus 4 is equal to 0. And now we solve. X will equal to a negative 4. And then x will equal to a positive 4. Those are our two solutions, negative 4 and positive 4. Again, that GCF of 3 did not have an x with it, so we didn't have to try and solve for that one. This last one is written differently. It already has parentheses, it's already factored. However, it's not equal to 0, so we can't just say this is equal to 49. We still have to get this equal to 0. But that means that we have to fix this term right here, this expression. This needs to be rewritten as x plus 2 times x plus 2 is equal to 49. We cannot set x plus 2 equal to 49 like we did here. We can only do that if it's equal to 0, and this is not. So we need to distribute this and get it back into a trinomial, and then we can get it equal to 0. So we have x squared plus, we're going to have 2x and then 2x again. So we're going to have plus 4x plus 4 is equal to 49. Now we can get it into standard form by subtracting the 49 from our constant. X squared plus 4x minus 45 is equal to 0. Now we can factor it. So we're going to have parentheses, because our GCF is 1. We can go and go straight into our factors, because this is also not a perfect square. So there's going to be two factors. We're going to have x and x. 45, and I want to get 4, so 9 times 5 will give me the 45. And then 9 minus 5 will give me a positive 4. So I have to have a positive 9 and a negative 5. Now we can set these expressions equal to 0. X plus 9 equals 0, and x minus 5 equals to 0. So our solutions are x equals negative 9 and x equals positive 5. So again, this one we had to make sure it was equal to 0. It was originally equal to 49, so we had to distribute this one out so we can get a trinomial, and then we could get it equal to 0 so that we could factor it as an expression equal to 0.